Okay, my friends, so let's do another example just to make sure we understand kind of the mechanics of the test, but also how to pull the information we need from, say, a block of text, and then be able to kind of take the values from that and plug them into our kind of 10-step plan. Okay, so this one, we're going to check the drug Prevnar, vaccine meant to prevent meningitis, okay, for kiddos. We gave it to 710 randomly sampled infants between 12 and 15 months of age, okay. 121 experienced loss of appetite out of the 710. And parenthetically, general population of infants lost appetite is 13.5%. Okay, so what this tells us is we want to see if there's any distinction between the loss of appetite of those on Prevnar and the loss of appetite in the general population. So the first thing I think we should do, since the loss of appetite in the general population is given as a percent, why don't we divide that 121 by the 710, and that's going to give us, yeah, just around 17%. Okay, so this, my dear friends, that sample statistic is 17%. That's greater than 13.5%. Is it significantly greater? I mean, it's 3.5% more, but is that significantly more than 13.5%? And that, my dear friends, is exactly why we do hypothesis tests. So let's try it. Okay, my friends, we got our handy-dandy hypothesis testing 10-step sheet here. We're definitely testing the proportion again because we're looking at the percent. Well, let's fill out these first two steps. The first thing is we are testing a proportion, the population proportion of whom? Well, in this case, the variable we're testing, little p, is equal to the proportion of infants, and let's try to spell that right, who experience appetite loss on Prevnar. All right. Now, we're going to compare that appetite loss to that in the general population. But now, to set up the hypotheses down here in step 3, let's slide up a little bit here, I'm going to go with the alternative first. The alternative is that proportion is going to be greater than 13.5%. Because the sample statistic we got was around 17%, and that's a larger number than 13.5. So the question is that just due to random chance, or does it appear to significantly be higher? Which means the null is going to be everything else, which is less than or equal to. Can I insert the symbol for that? I think I can. Symbol less than or equal to 13.5%. Okay, which distribution? It's going to be a z. For a proportion, it's always going to be a z. No reason to use anything else. Test statistic and p-value. This is where your Excel calculator comes in. So we're going to go back over to here, and we're going to fill in everything we need. We know that we had 121 out of 710, and we're comparing it against a null hypothesis of 0.135. Significance and confidence leave exactly as they are. The only thing we're going to have to change left is this, the type of tails. We're not looking at a left tail. We're looking at a right tail. Well, it's a right-tailed test because we are trying to see if the rate of appetite loss is greater. Okay, now first, a quick look at the graph. If you look at that graph, there's the p-value way out there on the right. It's very small, very, very small. Now, how small? That's where this part, the results, come in. Okay, there's our p-hat of 17%, just like we got from that quick Google calculation. According to statistics, it would have to get past a critical value of 1.645 standard deviations, and it does. Our data flies out to 2.762 standard deviations. That's well past the cutoff critical value of 1.645. The p-value echoes that by being very small, less than 5%. So let me make sure I got these right, 2.762 and 0.29. Come back to my template. The test statistic is 2.762. That's a lowercase z, not that it really matters, but. And the p-value is 0.29%. If I'm reading that correctly, that means there's only about a 3 in 1,000 chance that we should have seen the results we saw if Prevnar wasn't having a negative effect on these kids. That's the chance of random chance explaining the spike in loss of appetite. So since there's almost no chance that it was random chance, it must be whatever the other piece is, which is Prevnar. All right, what should we do? Well, this is a reject the null hypothesis. Absolutely. Yeah, the null hypothesis cannot be supported because we have escaped the confidence interval for that null hypothesis. Oh, indeed. So it appears, indeed, it appears that Prevnar is lowering appetite. Let's say that lowering, it's increasing loss of appetite. Let's make sure I say this right. It's increasing, kind of a weird thing, loss of appetite. That almost feels like I'm contradicting myself, and I sure as heck can't spell appetite right. Sure seems that Prevnar is increasing loss of appetite. All right. What type of error? Since we got a small p-value and we rejected the null, it's going to be a type 1 error, which means we claimed Prevnar was raising or increasing. Let's make sure. Let's try to say it correctly. Prevnar was increasing loss of appetite when it might not have been. It might not have been. Maybe we just got deviant data. And again, the deviant data part, you're never going to know if you have deviant data. It goes back to the problem with confidence. You never know if you're that one interval out of 20 that escapes the 95% confidence accidentally. The best you can do is act appropriately, which is reject the null hypothesis when you have a small p-value, and then just comment on the fact that you could be in error, but we did the right thing. All right, I think we got a pretty good idea about this. I got one more idea for one last video just to kind of drive home the point of how significance can change based on sample size. Just real quick video, hopefully. It's all going to be based in the Excel calculator. And then we'll get you in the homework.